Hello and welcome back to Calero Academy. Today we'll be doing a very interesting problem involving finding the area of a circle. Now, we're going to be using a couple of concepts in this problem, and if you feel really comfortable with the following topics, then I suggest you find another one of our videos. But if you're a bit shaky with one or two of them, then continue. So this is going to involve cyclic quadrilateral theorems, the similarity of triangles, the law of cosines, a really interesting theorem called the intersecting secant rule, something called this operating on central angles with the law of cosines, the trig algebra, lots of trig algebra, with trig identities and lots of trig expressions. Okay, so starting, now, the cyclic quadrilateral theorem states that if you have an inscribed quadrilateral, then supposing that this is alpha and this is beta, then the angle opposite this angle is going to be supplementary to this angle. So this is going to be equal to 180 minus alpha. And similarly, this is going to be equal to 180 degrees minus beta. This is helpful because then this tells us that this is equal to beta and this is equal to alpha. Now, what we're going to try to do first is find CP. We're going to do that by doing this neat trick of taking it and flipping it around. Because after all, look, APD and BPC are similar because they share the angles 60 degrees. Sorry, they gave that angle to us. Sorry about that. 60 degrees, alpha and beta. So they're similar. Except we have to flip it around because alpha is here and alpha is supposed to be over here. So we flip it. We get a new side. This is 8. This is C. This is P. This is alpha and this is beta. So now we can use similar triangles. Now we can use some arithmetic on similar triangles to find CP. This huge side on this side, divided by this side, is equal to this huge side divided by this side. Or that 18 divided by CP is equal to 7 plus CP on 8. After some cross multiplying and some quadratic equations, we'll get that CP is equal to plus or minus 9. But since minus 9 doesn't make sense in geometry, we can cross off that and write it as 9. Positive 9. Okay, now that we've found 9, CP being equal to 9, let's find BC. Using the law of cosines, BC squared is equal to 8 squared plus 9 squared minus 2 times 8 times 9 times cos of 60 degrees. This, after some simplification, will give us that BC is equal to root 73. Okay. Now, what we're going to do now is operate on the central angles. Okay, what I mean here is, let's have our origin O written there. Now, what we're going to try to do now is find this angle here, gamma, AOD. We're going to try to do that because that would help us try to find the radius. Because all these triangles are isosceles, with two sides being equal to the radii. Let's just name these two angles theta. They're going to be equal to each other because it's an isosceles triangle. So, what we're going to do now is operate on this central angle with the law of cosines. Equation 1 will have, after some simplification, we'll have that 4 times 73, we're getting that because this side is equal to 2 root 73. And wait, this side is equal to 2 root 73 because this side is equal to root 73. That is because the length of a side from the big triangle to the little triangle is 2 to 1, as you might have noticed. 10 to 18 is to 9 as 2 as this side, AD, is to root 73, or as 2 is to 1. So this is twice that side, 2 times root 73. So the law of cosines now, 4 times 73 is equal to 2r squared times 1 minus cos of AOD, gamma. Remember, this is just simplification from the actual cosine law. Now, equation 2. Let's operate on this central angle now. This central angle is simply equal to 180 degrees minus 2 theta from arithmetic. So 73 is equal to 2r squared times 1 minus cos of 180 degrees minus 2 theta. Now, before we go on, let's investigate now the intersecting secants rule. This is a really interesting theorem, which I actually never heard of before this video. It says that suppose we have two secants emanating from the same point, P, then the angle that they make, twice that angle, in our case 60 degrees, is equal to the angle AOD, gamma, minus the angle BOC, or 180 degrees, minus 2 theta. This implies that gamma is equal to 300 degrees minus 2 theta. Okay. Now, using this rule, we're going to put it into here. Now, put it into here. Sorry, we forgot to write a bracket there. There's 180 degrees. Because look, 180 degrees minus 2 theta is simply gamma minus 120 degrees. So we can rewrite this as 73 is equal to 2r squared times 1 minus cos of gamma minus 120 degrees. Okay. Now, what we do now is rewrite equation 1 as 4 times 73 divided by 1 minus cos of gamma is going to be equal to 2r squared, just by simple division. However, this is also equal to 73 on 1 minus cos of gamma minus 120 degrees. Also by simple division on this side. So, I think you can see where we're going. We're just going to divide throughout, get rid of the 73s, blah, blah, blah. After a lot of arithmetic, a lot of trigonometric algebra, we're going to drive down to 3 plus 3 times cos beta, 3 times 3 times cos gamma, is equal to 2 times root 3 times sine gamma. That's what we're going to get after a lot of arithmetic over here. So, then from there, what we're going to do is think. First, we just have to, let's try to get all the trigonometric functions on one side. This will lead to 1 is equal to 2 on root 3 sine gamma minus cos of gamma. That's just a little simple arithmetic from here to here. So, let's think. For what values of gamma is this true? What we have to do now is to find gamma, all we have to do is do two things. First of all, we have to bound gamma easily, and then we have to find the value or the values of gamma that satisfy this equation, because that's all we need to do. So first of all, let's try to bound gamma from below. Let's create a function f of x is equal to 2 root 3, f of gamma, in fact, is equal to 2 root 3 sine gamma minus cos of gamma. Now, we want to find gamma such that f of gamma is equal to 1. Now, let's go back to our diagram. For what value of gamma, what does gamma have to be more than? If we look at this, in fact, we see that the max that theta can be is 90 degrees, after all, otherwise it wouldn't be a triangle. However, if theta can be no more than 90 degrees, then gamma must be more than 300 degrees minus 2 times 90 degrees, which is 300 degrees minus 180 degrees, which is equal to 120 degrees. Therefore, gamma must be strictly more than 120 degrees. Now let's try to bound it from above. If, in fact, gamma is less than 180 degrees, it's impossible because then we wouldn't have a quadrilateral anymore. Imagine, if gamma here is more than 180 degrees, then we're imagining some weird, no longer quadrilateral shape. For example, A here and D here. That's just a weird pentagon or something. So, that's the idea. So therefore, gamma can be less than or equal to 180 degrees. Because after all, if gamma is 180 degrees, then it still makes sense. And here comes a tricky part, an extra concept, differential calculus. Now, here you're going to have to do some differential calculus, which I'm going to leave to you. What you're going to have to do is show that this function has a local maximum in this interval, and that this function increases to that maximum and then decreases. Or we just want to show this. It goes like this. Doesn't do anything funky like this. The reason I want you to do that is because what value of gamma instinctively seems like it's going to be equal to 1. Turns out 180 degrees works. So if 180 degrees works, then all we have to show is that there are no other values of gamma that work. And to show that, we just have to show that it starts at something more than 1, which is true. If you plug in 120 degrees into here, it starts off at something more than 1. So it starts off at more than 1, and then it increases to something even more than 1, consistently increases, and then decreases consistently until it reaches the last point in its domain, 180 degrees. And then it will equal to 1. By the way, the maxima will be 131 degrees, about 131 degrees. And that's it. If you look at it closely now, having found gamma being equal to 180 degrees, gamma is equal to 180 degrees satisfies this equation. If you look at this over here, that makes AD contain the origin O. It makes gamma equal to 180 degrees be like this, the diameter. And if AD is now the diameter, then the diameter is equal to 2 root 73, to the root of 73, and therefore the radius is equal to the root of 73. And therefore, the area of the circle, area, is equal to pi r squared, which is equal to 73 pi. And that's it. We're done. Thank you. This has been a wonderful experience to share with you. And also, this was not an easy production. There were an amazing amount of problems that amazing amount of approaches. There were lots of red herrings in this problem. And so, thank you for watching. This has been a Calero Academy production. We hope you come back for more. And also, Calero Academy will now start taking comments and suggestions for videos. For example, if you don't understand something, just put it in the comments section and we'll answer it. Or if you have a suggestion for a video, just put it down there and we'll try. Thank you for watching, and goodbye.